All right. Let's go ahead and go through this real quick. The way that this is set up with your side angle, side triangle, you have no choice but to start with your law of cosines. That we would have set up a squared equals, order does not matter on this, 6 squared plus 15 squared minus 2 times 6 times 15 times the cosine of the angle across from A, which would be 22. One step to solve for A, and that is to square root. And then I go to my calculator and I type all of that in. And we get that A comes out to, rounded to my nearest tenth, 9.7. Question so far? Okay. At this point, we actually have options to switch to law of sines if you would like. You can stick with law of cosines if you prefer. You need to show your setup so that I can know which of those to follow. Knowing that we're using a rounded number can put us off a little bit depending on our method, okay? So if we were to choose to switch to law of sines, I would put the 9.7 over the sine of 22. And this was the discussion we had at the end of class yesterday. If I'm going to switch to law of sines, which angle should I really do next? The smaller one, right? We don't want to use law of sines to find our biggest angle. And so as long as we just make sure we know that we don't find our middle angle second, because that's usually going to be when we use law of sines, however it's going to help you remember that, find B next. So we would do 6 over the sine of B. That I would do my cross multiply, use my inverse sine to solve for B, and it comes out to 13 degrees. And finally, our triangle sum theorem helps us find our last angle, which is 145. All right, questions on any of that? Today we're going to focus on not the side lengths and the angle measures, but the area of our triangles. And one of the things that we know is the area formula of a triangle, but we typically know the area formula of the triangle if it is given a height, right? And what I want to point out is, guys, I'm not at the beginning here changing your area formula. It's still going to be, what do you know from growing up, the area of a triangle? 1/2 base times height. But because these aren't right triangles that I'm handing you, finding that height, now go back to our ambiguous case. Didn't we talk about, okay, if I've got this oblique triangle ABC and we want to know the height, and I know maybe this angle right here, that finding the height was our adjacent side times the sine of our angle to find that height, right? Opposite and hypotenuse in that little right triangle that's created when I draw the height. So I do want to remind you that in an oblique triangle, we did find an area, a height formula that talked about that it was our adjacent side to our angle times the sine of our angle, right? That actually is what shows up in the place of height. And so you're doing today 1/2 base times height, but you don't have to go separately figure out the height. It's built into your formula. And so this formula looks very random and complex, but all it's doing is kind of like taking out a step for you. You don't have to go do the work to find the height using your trig. It's built into the formula. So it looks like some random formula, 1/2 BC sine A, right? That does not look like 1/2 base times height, right? But if I were to manipulate this into the letters that you're looking at, that would be 1/2 base times height, like we've always known. It's just building in our adjacent side times the sine of our angle to get the height, okay? Again, not a, like, memorize the letters type of thing. You can adapt this for any angle. What you need to understand is their relationship to that angle is that whatever angle we know, the two sides in the equation have to be the two sides that make up that angle or meet at that angle or are adjacent to that angle. So we have 1/2 BC times the sine of A. If we look at A, look at the sides on either side of it are B and C. So when can we use this area formula? When we have side angle side. You need to know the two sides and the what's called included angle that fall between those two sides. Letters don't matter, so I could do the same thing. If I were to know angle C, I would need to know sides B and A and do 1/2 B times A times the sine of C. Okay, as long as it's the two sides on either side of my angle. And that's it. And we just put it into that formula and it will tell us about the area of our triangle. So let's look at an example. Find the area of the triangle having two sides of length 24 meters and 10 meters and an included angle. Now, if we didn't have a picture, I want you to understand that when it talks about the included angle, as you draw your triangle and we wrote two sides that are 24 and 10, again, the included angle is the one that would connect those two sides. That's what it means by included angle. Round to the nearest tenth, round to the nearest square meter, which means whole number, okay? And our formula is just as easy as putting in those numbers in the correct spots. So 1/2, the two sides on either side of our angle, sine of our angle. Fill those in. We've got 10, we've got 24. If it's multiplication, does our order matter? No. So if you flip those, that's fine. Times the sine of our angle, 62 degrees. As always, be in degree mode on your calculator. And again, rounding very severely this chapter, so to the whole number on this one, nearest square meter. We are finding area, so our units are in square meters. Square units. Should come out to 106. And if you are not getting 106, let me know so I can help the calculator. Questions for me? Okay, we have a second area formula, and our second area formula actually has a name called Huron's formula. It is just a touch more work. Obviously, that last one was no work. So Huron's formula is what we will use if we know the three side lengths of our triangle. So notice a little bit different information. We can find the area if it's a side angle side, and now we can find the area if it's a side side side. Your formula for the area is the square root of S times S minus A times S minus B times S minus C, where A, B, and C are the three lengths of the sides of our triangle. S is the one thing you need to kind of remember how to find and what it is. S is what's called your semi-perimeter. And hopefully that will help you remember how to find it. Semi meaning half. Perimeter meaning adding up all your sides, and that's exactly how you find it, is that you find the perimeter and you cut it in half. That's your semi-perimeter, or S, and that's the number that will go in those four spots where it says S in our formula. Any questions so far? We haven't done an example yet. Anyone still need this page? Okay, so looking at an example here, they give us the triangle with side lengths of 12 and 16 and 24. A picture is completely not necessary. However, we're kind of in the habit of drawing that, and that's fine. You absolutely can go draw a picture if you want. It really doesn't do anything for us on this one because we don't even really need to know what is where. To do this formula, the first thing we find is the semi-perimeter. So 1/2 times the perimeter, which is 12 plus 16 plus 24. Remember that addition, order does not matter. So add up your sides, divide by 2, or add up your sides, multiply by 1/2. This number then is what shows up in each of our different spots where it said S for semi-perimeter in our formula. Your semi-perimeter on this one is 26. And now we can move to Huron's area formula. It does start with the square root. It starts with just a single S by itself, one semi-perimeter by itself, and then take that semi-perimeter and subtract each of your sides. Order does not matter as long as they're all in there. So 26 minus 12, 26 minus 16, and 26 minus 24. You can literally go just type it that way into your calculator. Some people like to figure out what 26 minus 12 is, 26 minus 16, 26 minus 24. That's up to you and your personal preference of how you're going to go type that in. I would just suggest using your calculator and not making a mental math error. It does say round to the nearest yard. So again, we will go to our nearest whole number. And let's check our calculators. Should be getting 83 rounded to our nearest whole number. 5. Just make sure you guys were 85 to our nearest whole number. All right. Other than me putting a wrong answer up there, any questions? Okay. Without me telling you which formula to use, find the area of these two triangles. Would you mind putting that in your answer on the board for the first one? On the board. If you wouldn't mind. Would you mind putting that on the board here? Just your equation and answer. Just the equation and then the answer. Yes, so yes. All right. Let's look what we got on the board. How'd they do? Did good, didn't they? Thank you, thank you. All right, guys, that's it. That's the end of, and what I'm asking today then is that you get this done in class, okay? Walk out of here, have nothing to do today because you're gonna finish it now.